Right, good morning everyone. Okay, without further ado, let's start. Okay, before I go into the lesson, I have one announcement to make. So this one for student from section 8, right? So I will need to cancel the class on Tuesday, 22nd October, because I have to bring my daughter for a checkup, okay, at the government clinic. So it's not possible to arrange another day. So I have to cancel the class on Tuesday next week, right, for students section 8, practical section 8, as well as tutorial section 8, right? And I am proposing to replace the class online because I think it's quite difficult to find physical places for 2 hours direct. Okay, so I am proposing to replace the class on 25th October, Friday, right? The tutorial will be from 3 to 4, and for practical from 4 to 5, and I will conduct the class via my times, okay? And the session will be recorded, so for those who cannot attend, you can view the recording later, all right? And the topic will be covering tutorial 4 and lab number 4. So if anyone from student section 8 would like to propose a different date, okay, or a time, or you prefer physical as well, so please let me know. I will try to arrange one, right? But this is what I am proposing at the moment, okay, for students from practical and tutorial section 8. Okay, right, so so let's move on to the next one. Okay, I have also would like a favor from you, all right? I have shared one student guide under the homework section, all right? So this is the student guide for you to enroll or to register yourself in the Cisco Networking Academy, all right? So from next week onward, we will be using a simulation tool called Cisco Packet Tracer, all right? So first of all, you need to register with the Cisco Academy. So you register yourself, you follow the steps that I give here. Okay, has anyone here registered yourself in the Cisco Academy already? Not yet. Anyone here have registered? Not yet, okay. That's fine, you go back, okay. So you follow the steps that I give here. You go to the link, okay, click on the login, sign up. Okay, please use your Taylor's email. Okay, use your student Taylor's email. Fill up all the information. Okay, use your real name, right? Your real information. Sign up, right? So once you are registered with the Cisco Networking Academy, you will be able to access the portal. All right, so this is where you can see all the features in the academy. So what I want you to do next is that I would like you to browse the catalog here. Okay, there'll be a catalog button, right? And then you search for Cisco Packet Tracer. Okay, you type in the Cisco Packet Tracer and then search. You search as a learner. So it will propose for you these four modules. All right? So please enroll on all these modules. Okay, you just click the module and then basically you will be enrolled in the module. So throughout the next lab session, you will be completing the modules, these modules online, right? And there will be a tutored activity as well prepared by Cisco for you to learn how to use Cisco Packet Tracer. So basically you will learn Cisco Packet Tracer to complete your assignment as well. Okay, so please go back. Hopefully by next week when we start our lab, you are already registered in the academy and you are already enrolled in the modules, right? Okay, so I hope you can do this homework. Okay, this is your homework. So there's no mark for this, definitely. But please, what I meant here is that you need to try to do this at home, right, before you attempt the tutorial next week. Okay, any question? Any question? No question. Right. Okay, so if there's no question, so I will remind you again in the WhatsApp group what you need to do. Okay, right. So, so let's start with this lesson. Right. For this week, right, we will learn how operating system manage file. Okay, so on your machine, right, you have so many files that you have created. Okay, so you might be wondering how this operating system allow me to create a file and then edit it and then save it. Okay, save it in the hard disk memory. Okay, then later on when you shut down your machine, you open it back, you still can see your file and you still can access the file. Alright, so how does OS allow me to do that? So let's look at how OS manage file. Alright, so first of all, we might want to know what is file. Okay, so files refers to data collections created by users. So you have a lot of data, right? So you are the one who create the data, okay, and you want to collect that and save that data in your machine. So the file system is one of the most important parts of the OS, okay, for the user, right? So what makes a file a file? Okay, so a file becomes a file, okay? An object in your system, in your machine, becomes a file when it possesses these three properties, right? First, it should exist long term. Okay, you want to save it and you want to use it later. Okay, right. So files are stored on disk or other secondary storage, and it do not disappear when you log off. It should be persisted in the system long term, right? And then the file also should be shareable between processes. Okay, so usually file have names so that you can always refer to it again, right? And it can have associated access permissions that permit control sharing, right? For example, in Linux last week, we learned how to access password file, for example, right? So this password file is basically you can only access this as a sudo, as super user. So super user you can edit, but as other user you can only read. Okay, you can only read but you cannot edit, right? For example. Okay, so there must be some kind of a shareable features that support sharing between processes. Okay, and the file as well should have a structure. Okay, so files can be organized into hierarchical or more complex structure, okay, to reflect the relationships among the files. Okay, something that you see inside your Windows Explorer here. Okay, they are hierarchical, all right, and they may be related. For example, here in the gallery pictures, I just put everything about pictures, images, right, and so on. So they are somehow related. All right, so let's move on to the next slide. So file system. So in your operating system, you will have a file system. So what is file system? So you know what file is already. So now let's look at the system that manage the file. So this file system, it provides a means, okay, a way to store data organized as files, okay, as well as a collection of functions that can be performed on files, right? So it also maintains a set of attributes associated with the file, right? Something that you see when you do this, ls minus l. You have done this. For those who are going to have lab today, you're going to do it today, right? So these are all a set of attributes associated with the file. So you know when it was created, you know the time it was created, by whom, and what are the files permission associated with this file. So these are all a set of attributes maintained by the file system, right? Okay. So what are the typical operations that you can do to a file? You can create, you can delete, you can open a file if it is already saved, right? You can close it, you can read, you can write. Okay? Some executable file you can execute, .exe, right? Okay. Right, so file structure. So what constitutes a file? So there are 4 terms that are commonly used when you discuss a file. So first is field, and then record, and then file, and then you have database, right? Okay. So now let's look at the term. Field, this is the most basic element of data, okay? And usually it contains a single value. So every single character that you type in your Word document, that is a field, right? And a field can be fixed length or it can be variable length, okay? Something that you see, if you remember, in your password file. So remember, in the password file, you store, you have one line represent one user, and for that user, it has a number of field, okay, that will store some data or value about that user. So this is the field. So you can see this type of field is of variable length, okay, and it only contains one set of data, okay, or value for that field. All right, so that is field. Okay, and then from field, you can have record. Okay, so record here refers to collection of related fields, okay, that can be treated as a unit by some application program. It can also have a fixed length or a variable length. So here you have field, okay, and the entire line here, this is one record of a user, okay. So in this user record, you have several fields, related fields to describe that user, okay. So this is one record, one line, one record, depending on the application that you use. For this password file, one line represent one record, okay. Right, one record of a user. Okay, so now from record, you go up to files. So what is file? Okay, so files here are collection of similar records, right? So this will be treated as a single entity, and you may be referencing the file using a name, right? So when you want to access the file, usually you will have some restrictions to access the file. For example, in this password file, okay, so you can see here you have many records of users, okay. So the collections of all user records here, you save in this file called password. So you can see, so this file contains collections of users records, and it has a name. And if you remember last week, to access this file, you have to become super user. So there is an access control, okay, to view or to read the file, right? So that is file. So the fourth structure is database, right? So you have learned database system, right? In database module, you did? Yes, okay. So database is a little bit different category of structure, okay. So it refers to the collection of related data, okay. So data in databases usually are related, and there is a relationship among elements of data that you explicitly coded within your data, right? So it's designed for use by a number of different applications, and it consists of one or more types of files. Okay, so files here, if you refer to your database, this is something equivalent to table. You have table, right? So you create table in your database. So that table have similar connotation to file in the file hierarchy, right? File system, right? So what file management is all about? So you already have file systems. You learn about file structure. So let's look at management. How the system manage file. So first of all, the file management system must meet the data management needs of the user. So what the user wants? Okay, so they will come with the requirements. So your file management system should be able to address the requirement by the user. It should be guaranteed that the data in the file are all valid. Okay, not something insecure or invalid. Okay, the management system as well should optimize the performance, right? It should provide I/O support for a variety of storage device types. So the file should be able to access the different types of memory devices, USB, RAM, hard disk drive, on the cloud, and so on. Okay, it should minimize the potential for loss or destroyed data. Okay, your file should be less corrupted, should have less corrupted rate. Okay, not corruption rate. Okay, provide a standardized set of I/O interface routine to user processes. So what it means, when I want to save, for example, I create this PDF file. When I want to save it on my hard disk, I do not need to install a different driver, or I do not need to buy a new device to help me save the file in the hard disk. If I want to save it on USB, also I do not need to, to buy a different device to help me, to help my OS to save it on the USB, right? So it provides a uniform, standardized set of I/O interface that will allow me to save or to perform operations on my file saved in different devices, right? And it also provides I/O support for multiple users in the case of multiple user system. If you have multiple users using your system, they as well should be able to access the file on memory devices. All right. So these are the minimal user requirements. Usually, each user, okay, so how this file system should support the user, right? So user, using the file management system up here, should be able to create, delete, read, write, and modify files, okay? User also may have control access to other users' file. You learned this already this week. How you can use CH mode to change permission to users, okay, to access files, right? User also may control what type of accesses are allowed to the user's file. User should be able to move data between files. You can copy and paste. Okay, you can copy images from browser and put it inside your Word documents, right? User should be able to backup and recover files in case of damage, right? So they can make a backup. And user as well should be able to access his or her files by name rather than using numeric identifier. So each file should be named in the form that human can understand, okay, and can be easily used and recalled, right? So this is what a user should be able to do via means of file management systems. All right. So now let's see at the file system architecture. What does it consist of? Okay. Remember here you have your user program that create the file, that use the file. Okay, for example here, okay, we have the PDF, right? The PDF file here. Okay, so the PDF file, when I want to save that PDF file, there are five ways the operating system can organize my file in the system. Okay, either using pile, sequential, index, or hash. So this is file organization, something like this. All right. And then there is a logical I/O. Okay, basic I/O supervisor. I/O here stands for input/output. Okay, and then you have basic file system. Okay, and then you have the driver, which is the hardware devices, hardware memory devices. Either it's going to be your disk drive, your hard disk drive, or USB disk drive, or it could be a tape device. You want to save it in the tape, which I think nowadays, modern days, you rarely see tapes anymore. Okay, all right. But anyway, now we will discuss this diagram from bottom to the top. Now we look at device drivers first. So in this case, you can see there are two types of device drivers. First is disk, another one is tape. All right. So what is the device drivers? Okay, this is the lowest level program, okay, running inside your operating system. Basically, these device drivers will communicate directly with the peripheral devices. It will communicate directly with your hard disk drive and with your USB hardware. Again, communicate directly with the hardware. So it is responsible for starting I/O operations on the device. What do you want to do? Save, open, delete, all right? And it will also process the completion of an I/O request. So let's say if I want to open the file, okay? So once I click this open, I double click this action, okay, this file. What happens is that the disk driver will copy the file on the hard disk drive and bring it into the RAM, okay, for the CPU to process, and you can see the file and you can edit and whatnot, right? So that is the function of device drivers, to bring the file from the hard disk drive into the operating system, into your computer. Okay. And then it is considered to be part of the operating system as well. So you have your device drivers, and then you have basic file system. Okay. So basic file system here is also referred to as the physical I/O level. Okay, so the main primary function is it serves as a primary interface with the environment outside the computer system, and it deals with blocks of data that are exchanged with disk or tape system. Okay, so let's look at, I think I will discuss this with the help of this diagram. This one. Okay, so here, okay, I move forward a little bit, and then we can look at the architecture again. So here you have two concerns. So one is the operating system concerns, and this one is file management concerns. Okay, two parts. Okay, so let's look at the operating system concerns first. Okay, so this is your memory device. Okay, so inside your memory device, okay, your memory device, remember this week in tutorial 4, we discussed about partition and frame, okay, where you divide your memory space into fixed partition, or you divide it into fixed frames, okay, using paging. Okay, so here in your memory device, you have physical blocks in your secondary storage, right? Okay, and then let me see. Okay, maybe I will start from the beginning so that you will see it clearly. Okay, let's start from the beginning. So just now I mentioned you have your hard disk drive, okay, here, okay, which you have divided into different partitions, okay, or different frames. So you can see, so these are all the free space, okay, within your hard disk drive. So now, user and program commands. Right, so I create this file and I want to save it. Right, you want to save this file. So you click save somewhere, okay, and then save as. Right, so now there will be this user control here, which allow you to decide what operation you want to do to the file, and then the file that you want to operate on. Okay, so this is the operation and the file name. So in this case, I am editing the file, and the file name is lecture 4 file systems management. So this is my control as a user, okay, user access control. And then this file, where is it located? Okay, so it is located somewhere, okay, in my Windows Explorer, in my Windows directory, okay, somewhere here in the teaching materials, okay, and lecture, for example. So these are all the lecture slides that I put inside. So this is what we meant by directory management. Okay, you manage the file. Where within your file hierarchy you want to place and store this file. So this is what we meant by directory management. How the file will be structured? Okay, so we will learn this one later. There will be a file structure. Whether this is a field, a record, a database, right? So remember just now, file is a collection of records, right? So this is a record of slides. Okay, so this particular file has records of slides. So whatever characters that I type here, okay, this is a field, right? So this will be the file structure that will be stored inside the hard disk. All right, so now we look at the architecture again. So we have this user program, okay? So this is the organization, how we want to organize the file on the hard disk, all right? So there are several ways. Okay, so now we look at this one back. Okay, so now, so file structure, you have fields, you have records, okay? And then you manipulate the file, okay? You edit, you cut, paste here and there, okay, and so on. So that is access method. And then now you have records, okay? So your file structure now will be transformed into records that can later on will be saved inside the hard disk, right? So this record will need to be saved in the hard disk, and it will be organized in this way, okay? Right. And then you have the logical I/O. So now how we want to organize this? If you remember yesterday, you learned about page table in this week. For tutorial, that for those who have already completed the tutorial, you have page table, right? Where the operating system remember which page is being stored in which frame, right? So same thing here, you have logical I/O. So now the operating system will need to remember, right? So this particular file, in which particular frame in the memory it is being stored. Okay, so you have what we call the logical I/O. Okay, and then you have this basic I/O supervisor. So basic I/O supervisor means, what does it do? So this one is responsible for all file I/O initiation. Let's say if I want to save the file inside the hard disk. So this basic I/O supervisor will initiate a communication with the hard disk. Okay, it will knock the door of the hard disk. Okay, hard disk, this process wants to save the file here, based on the logical I/O. Okay, so that is the work of basic I/O supervisor. So once it complete the saving, for example, then it will terminate the communication. Right? So that is the function of basic I/O. And then we have, go up here, basic file system. Okay. And then the disk drive. So basic file system here, right? So you have the record coming in just now. Okay, so now you need, now the operating system will need to manage how it want to place the records into the block. Okay, so that is file system, basic file system, right? So it will put in the, it will buffer the data coming from the system, okay? And then this scheduling here, which is the disk driver, will figure out in which particular place it want to place the file. Okay, something that we learned this week as well. Right, on the paging, looking at which frame is free. So let's use some replacement policy or placement algorithm to figure out where to place this block of data to. Right, so all are running within this process. Okay, all right. Okay, so now we will look at file organization. So in this part, so how do this operating system organize a file? Okay, so file organization is the logical structuring of the record, how the record should be structured, okay, as determined by the way in which they are accessed, right? So to choose which file organization, there are several criteria that you can choose. First, when you want to organize the record, so it should have the shortest access time as much as possible, right? For example here, when I okay, for example, this is the file that contains user records, okay? So now if I want to find file user Zainab, so how do I search? How do I access the record? So the time should be shortest as much as possible, accessing the record in the file, right? Okay, and then we have ease of update. You can easily update, okay? So when you create a new user last time, it's easy to update the file. Do you need to go to the file and enter the record? No need. You just use the command add user and this file will be updated, right? The user record will be automatically added to the file. So there's no need for you to go and edit, right? So easy to update in this case, right? Okay, so easy to update. Then economy of storage. It should not consume as much space as it can, right? So try to reduce the use of storage. Simple to maintain, okay, simple to maintain. And the file should be reliable. Whenever I open the file, I should be able to see all the content, the right content, the valid content. There's no missing font, there's no missing data, there's no missing record. Okay, so that's what we meant by reliability. Right? So priority of criteria will depend on the application that will use the file. So which criteria to choose depend on what the user needs. Okay? Right. So now there are 5 common file organizations. Of course, if you look at the literature, there are a lot more organizations in the currently being researched by many researchers. But these are the 5 common file organization. Right? So we have the index file, the direct or hash file, the pile, the sequential file, and the index sequential file. Right. So now, pile file. What is pile file? Piling. Piling means you keep on piling. New data come in, pile. Add on, add on, add on, add on, add on. That's all. That's what you meant by piling. Right? So for pile file, the record will have, you have a variable length records. Some records are long, some records are short. Okay, the set of fields also vary. Some record do not have certain fields. Okay, and it is added on to the list in the chronological order according to the time it comes in. Right? Something like what you see here inside the password file. You add on the user, you will piling up. Okay, added into the file. You can see the size of the record also are not the same. Okay, some are long, some are short. Alright. Okay, so that is pile file. And then we have sequential file. Right? Okay. So, okay, come back to here. So this is a pile file. This is the least complicated form of file organization. Data are collected in the order they arrive. Okay. So each record consists of one burst of data. You add a new user, you have one user record. Okay, so the purpose is to simply to accumulate the mass of data and save it. And if you want to find, remember last time, how do you find the record of the new user? You scroll down, alright? You scroll down to the last 2 lines. So it's okay if you have few users, but if you have millions of users, do you want to scroll down? It takes ages to scroll down. So the search for a particular record can be exhaustive, right? So this is PAL file. And then you have sequential file. Okay, for sequential file, you have a fixed length records. All records have the same size. Same size, same number of characters. Okay, and then it has also similar fixed set of fields. So all records will have similar set of fields, okay, in the order. And the sequential order will be based on some key field. For example, maybe user ID that will differentiate each of the record. For example, users, a student. So all of you have one unique user ID. So we can identify you using your ID. Okay. So this is the most common form of file structure. So a fixed format is used for records. Okay. And there will be a key field that uniquely identify the record. For example, number 1, 2, 3, 4, 5, and so on. That can also be a key field. All right. So basically, this sequential file, this one is used in batch applications. You have multiple similar record that you need to process. Okay. So in only organization that is easily stored on tape as well as on disk. So it's easy to save this file on the hard disk drive and also on the tape drive. Okay. Right. So this is sequential file. And then we have index sequential file. Okay. So for index sequential file, basically this is a sequential file, but the system add on some index. Okay, have you been to the library? Our library here? Have you searched for books? Okay, do you use the index number? Okay, so that is how indexing works as well. So there will be like an address. Okay, an address to identify a particular record in the file. Okay, so it will add on this addressing scheme or index to the file to support random access. So whenever I want to find, for example, student name city, there are so many cities, okay, in the campus. So we can start with SIT. Okay, so let's start with SIT and then you deep down deeper to find which city you are looking for. So that's what we meant by index. Okay, indexing. Right? So it allows you to search at random. If not, then you have to scroll down. If you use PAL, to scroll down the list up and down to find city. Right? So it will greatly reduce the time required to access a single record, and you can also use multiple level indexing, okay, to provide greater access efficiency. Right? So the main idea here is to help you to access the file. You can also have index file. So this one just now index sequential file. You can also have index file, okay, which is not sequential. Right? So records are accessed only through their indexes. Okay? And for this matter, the record can be of variable length. So that's why it is not sequential. Okay, remember sequential, the length is fixed. All records have the same length. But in the case where you might have records that do not have similar length, similar size, then you can use index file. Okay. So it will be exhaustive as well. Okay, if you contain only one entry for every record in the main file. So you can also use partial index, okay, entry to record where the field of interest exists. You want to zoom in further to find the data for a particular field in that record. For example, in the airline system, okay, you might go to the counter, you might want to double check, where do I sit? I want to change my seating. Okay, so then there are several indexing that need to be done. First is to identify your flight ticket number, flight ticket number, okay, and then to the field, which is the seating field. Okay, so this is what we meant by index file, right? And then you have another organization, which is direct or hash file. Okay, so for direct or hash file, it accesses the file, any block, okay, any partition in the memory directly, okay, by knowing the address. What is the starting address, memory address of that particular block? Okay, so you mention the address, then it will point you, it will bring you to that particular partition, right? So it makes use of an hashing, okay, on the key value. And when do you need to use this method, this organization? You use it when you need to have a very rapid access. You want to access that particular partition directly, so rapid. You use a fixed length record because you are accessing a partition, okay, a partition. And this record usually will be accessed one at a time, okay, one partition at a time. You cannot access multiple partitions at the same time, okay, if you use this organization, right? So, for example, directory, okay, this one, okay, you just can, straight away, you can pinpoint where you want, which file you want to open. There's no way that I need to sequentially list, scroll down my entire file system and find what file I want to open. I just choose what I want and I click. So this is direct. Okay. Okay, and then pricing tables, schedules, name lists, and so on. Okay, I will create B trees. Okay, you don't have to study B trees. Right. Okay. So let's look at this one. Okay, the operations performed on the directory. Right. To further understand the requirement for a file structure. Okay, so it is helpful as well to consider the type of operations that may be performed on the file. So it's something that we usually do. Okay, you can search a file, you can create files, you can delete files, you can list directory, something that you do in your Linux, right? You can list. Okay. Okay, you can list, right? And then you can also update directory. You can add, you can remove your files. Alright, so these are some operations performed on a directory. Not a file, directory. Okay. Okay, there are two-level scheme here. Okay. So if you look at your Windows, so if you have your Windows with you, you might want to look at your Windows here. So let's see if I go to my C. Okay, this is my C. This computer I got from Taylor's, not mine. Okay, so Taylor's, if I resign from this university, so new staff come in, they might give this one to new employee. So they might create a new account. So you can see here under users, I can see all the users registered in the system. This is mine, right? So there are two-level scheme in the directory management. Okay, so there is one directory for each user, and there'll be a master directory. Okay, so in this one, so this is the user directory, and the users or the C itself is the master directory, right? So you can see here, there is one directory for each user and one for master directory. So master directory has an entry for each user directory, providing address and access control information. So within the hard disk, right? So you can see here, inside the user, there will be like a partition as well for every users created in the system, right? Okay, so each user directory is a simple list of the file of that user. So if I open my directory here, So file folder. So these are all the files part under my user directory that I can access as Zainab lah. Okay, S1122x86 users. Alright. And then names. Okay, names within the directory must be unique only within the collection of files of a single user. So that's why you cannot have two files with the same name. If you do have one, what does it tells you? Okay, it tells you to rename, or it will add on some weird characters at the back. Okay, 1, 2, or 3. And file system can easily enforce access restriction on directories. So basically, similar like Linux, you can also enforce some permission here. Okay, who can access and do what in your folder on your files. Alright, so this is what we call the two-level scheme. So you basically have master directory, and then you have subdirectory. Okay, and then with the subdirectory, you might have subdirectory. Okay, sub, and then this is where your file will be. Right? Okay, so this is two-level scheme. Right, so far any question? No question? Okay, if there's no question, I will stop here. Okay, let's take attendance. I will continue discussing the rest while we discuss our tutorial question. Right? Okay, so again, I would like to take this opportunity. For student section 8, there will be no class next Tuesday, and I will replace it online on Friday. Okay, so I will share the online class link via WhatsApp and in my times as well. And please don't forget to complete the homework. Okay, to register yourself into Cisco Networking Academy, so that when you come to the lab next week, you already have access to the academy. Okay, don't wait until the lab session, practical session. Madam, practical session already start, eh? Madam, how do we register? Okay, so please do this at home. You don't know, you ask in the WhatsApp group. We will assist from there. Okay, all right. So I think that's all. Thank you so much.